The sine law states that for triangle ABC, now one thing, when we name a triangle, the vertices or the angles have uppercase letters, right? So angle A, angle B, angle C. The sides are named with the lowercase letter of the angle which they are opposite. So opposite angle A is side little a. Opposite angle B is side little b. And opposite angle C is side little c, and so on, right? So if you're given something like a question that says triangle PQR, then you know you're going to draw a triangle. You're going to label one of the angles P, one of the angles Q, one of the angles R. Once you've done that, little p, little q, little r, just go where they go. The sine law says that for this triangle, the ratio of little a divided by sine A is equal to the ratio of little b. So the length of side B divided by the sine of angle B is equal to the length of side C divided by the sine of angle C. And also, or because I think you only get one of these, but you can just basically flip it over, right? If these ratios are the same, then flipping them over, those ratios will be the same as well. So the sine of angle A over little a is equal to the sine of angle B over little b is equal to the sine of angle C over little c. Now the way that we're going to use this is we're just going to take four quantities, like angle A, angle B, little a, little b. If we know three of those quantities, we can use the sine law to solve for the fourth. Okay? Now you'll notice each of these quantities has like the b over sine b, like this. So we need what is called a known pair. So I need a pair, that is an angle and a side opposite. In order to use the sine law, I need to know the measure of an angle and the length of the side opposite that angle, okay? For one of those, A, B, or C, I must have a known pair. Then I need to know one other thing, like angle A. Then I can solve for little a, or, you know, and so on. All right, let's move this down. Do it this way? No, it goes to the next page. Okay, so let's drag down here. So you're going to use this form to determine a side. In other words, you want to put the unknown up top, the thing I want to find. If I want to find a side, it's easier to put the thing I want to find up top. If I want to find an angle, it's easier to put the angle up top, that form. Okay. On your formula sheet, you're only ever going to get one form, but it doesn't matter. Just flip it over for the other form. To prove the sine law, you say, prove that. We construct an altitude AD. So we take our triangle ABC with little a, little b, little c. We construct an altitude AD, and we say in triangle ABD, so triangle ABD is from here to here to here, this triangle, the left-hand side. We know that the sine of angle B is h over c. Notice we've made a right-angle triangle, right? Now we can use SOHCAHTOA. The sine of angle B is opposite over hypotenuse, which is h over c, which means h is equal to what? Yeah, sine B times c, or we're going to write c sine B. In triangle ACD, and the triangle on the right-hand side, so A to C to D, the sine of angle C is opposite over hypotenuse, which is what? H over B, which means that H is equal to B sine C. Since H is the same for both equations, if we know that H is C sine B and B sine C, what do we know? These two things must be equal. Okay, so we have C sine B is equal to C sine B is equal to B sine C. If we divide both sides by sine B over sine C, or sorry, sine B times sine C. Sine B sine C, sine B sine C. Then the sine B's divide out, leaving you with 1s, and the sine C's here divide out, leaving us with C over sine C is equal to B over sine B. Just drag this down. Okay, so we have C over sine C is equal to B over sine B. By drawing the altitude from C and using similar steps, you can show that A over sine A is equal to B over sine B, and therefore, sine law proved, A over sine A is equal to B over sine B is equal to C over sine C, by various properties, transitive property, and all that good stuff. Okay. Proof of the sine law just requires you to make it into a 90-degree triangle, use some right angle triangle trig, and show that, hey, look, these ratios are the same. Okay, kind of a handy thing. To use the sine law to determine a missing side, we will use A over sine A equals B over sine B. So we only have two of the three things, right? Because you're solving for one thing. We will need to know a side and its opposite angle. Okay, that's the known pair. Okay, so you need a known pair. You need the side and the opposite angle. So in this case, you would need to know angle A and this. You would also need to know this. And then that's what you would find, right? You would find the missing side, the unknown side. To use the sine law to determine a missing angle, same deal, right? Now you feel free to substitute your own letters there. If it's triangle PQR, you might be going sine of angle P over little p is equal to sine of angle Q over little q. We need to know an angle and its opposite side. So again, the known pair. Right? In this case, A and, hang on, let's drag this down a bit. You got a known pair, and then you've got a third thing, right? Every equation, because you're only pairing them up, involves four quantities, right? Two angles, two sides. So you need three of the four quantities in order to solve. Okay. Make sense? So far, so good. So quiz tomorrow will not include sine law, right? Everything up to, but not including sine law. That's today. Solve for x, rounded to the nearest hundredth. Okay, so we can label this any labels you want. So we'll go with A, B, C. That makes x little b. That makes this little a. That makes this little c. Do we have a known pair? Yeah, so we have angle A and side A. Since we want to find an unknown side, we're going to set it up like this way. Little a over sine A is equal to little b over sine B. It just makes it easier, right? Because then the thing we want to find is on top, so we just multiply both sides by what's on the bottom, and you solve. If you stick what you want to find on the bottom, then you got to cross multiply and then divide. Okay, filling in. Little a. Oh, actually, before we fill it in, we can actually kind of solve this equation and say, I want to find little b, and it's going to be equal to a times the sine of b over the sine of a. Okay, so in other words, let's just solve the equation for what we want to find. Now we can just substitute in, right? Instead of substituting in and then doing the solving, we could do the solution thing. Now we just substitute in, right? Remember the secret to math? Formula, substitution, answer. Okay, so little b, in this case, which is x, is little a, which is 10, times the sine of angle b, which is 50, over the sine of 70. Okay, so it's a calculator problem. Making sure your calculator is in what mode? Degrees. Okay, here's calculator. Turn on calculator. Clear mode. Set to degrees. Okay, so just go over to degree, hit enter, and then you can quit out. If you want to check if you're in degrees, just do the sine of 30. Right? Sine of 30 should be 0.5. Okay, so we want 10 sine 50, close, oops. Sine 50, close bracket, divided by sine 70. Close bracket to make it look nice for the video recording. If you don't close it, it's fine. It'll still work it out. Right? It'll throw one in. And hit enter. And we get solved to the nearest hundredth, 8.15. George Polio, Hungarian mathematician. 4-step problem solving method. Understand, plan, do, look back. Understand. They want me to find x. That's about all. And they give me 7 degrees 10. They gave me the side a known pair, so I can use Sine Law. I'm solving for an unknown side, so I'm going to set up this form of the Sine Law. I'm going to pre-solve, so I'm going to solve for the thing I want to find, right? And then I'm going to substitute in. Now, does it make sense that x is smaller than 10? And if so, why? Yep.
So can you only use Sine Law when it's not a right triangle?
You can use it in a right triangle as well, but you don't have to. It'll work because the sine of 90 degrees is 1. So you'll basically just end up with opposite over hypotenuse kind of thing. Okay, does it make sense that x is less than 10, and if so, why? Yep. There is no hypotenuse. But you're on the right track.
The other side is 10, and the old x side just looks smaller.
It looks smaller,
Yeah.
Therefore,
Yeah.
diagrams might not be correct. But if you think about it, so for those of you watching on video, I'm holding my hands together. If I open up my hands and the angle there increases, what happens to the side length? It's getting bigger, right? Can't use the same in this case. It's the same. No, it's getting bigger. Which means that the side opposite the biggest angle must be the biggest side, right? So 70 degrees, what's the measure of this angle here, by the way? What's that you say? 60 degrees, because the angles in a triangle add up to 180. So no hypotenuse. So we know that this is the largest angle, and therefore this is the largest side. That side C fits how in A and B? Is it between, bigger than, smaller than? It's going to be in between, right? So largest angle is opposite the largest side. The next largest, right? And therefore, this side here is going to be the smallest because it's opposite the smallest angle. Okay? So just think about a triangle. When you make a triangle, the larger the side gets, the larger the angle gets, the greater the length of the side opposite it. Okay, and then when you hit 90, you draw the right triangle. Okay, questions? Moving on. In triangle PQPOR. Oh, see, now here's the Q. Let's go Q. Oh, they changed it? Okay, now it's Q. Q's all right. In triangle PQR, angle P equals 60 and Q equals and R equals. First step.
Draw a picture.
Draw a picture. Yes. Draw a picture. It doesn't matter how bad your picture is. You could even draw a right-angled triangle, which would not be correct in this instance, but, okay? So a picture or a sketch is simply a placeholder for information, right? And that's all we need. So I don't need to draw. I mean, I could try and be reasonable. You know, angle P is 63 degrees, so, you know, let's go here. So that's P, and Q is 25 degrees, so I need that to be relatively, that'll be too big, so we'll go up here. So, okay, there's Q. So here's 63 degrees, 25 degrees. Here's R. Little r is 12 centimeters. And we are to determine the perimeter, which means we need to find what? All three sides. Do we have a known pair? Sine law says you need a known pair.
Yes.
So what are we missing, but how can we get it? Yep.
Since all the angles are supposed to add up to 180,
Yep.
take 180 and subtract 63 and 25.
Okay. So 63 and 25 is what? 88?
92.
63 and 25 is 92?
No, if you
Yeah. Just. Yeah. So, that's the deal. This is going to happen a lot in sine law. So basically, if you know two angles, you know all three angles. Right? So even if you don't think you need to list it, sometimes when you draw the diagram and you say, I got these two, I'm just going to put the third angle in. Right? Regardless. At which point, any question becomes a sine law question as long as you know one side. Right? Because now you have a known pair. Okay, so we got to do two sine laws, right? One's for P, little p, one's for Q. So, mind your P's and Q's. Solve. So here's little p. Here's little q. So, set it up and solve it. Start with formulas, right? Oops, can't use q there. Now, once you calculated P, do not use it in a further calculation, right? Don't say, oh, now I know this sine, and it's this, because it's going to be some rounded value, right? But when do we round? At the end, okay? So, if we ever do have to use a calculated value, and that sometimes occurs, you're just going to leave the full number in your calculator and then use it. Okay. In this case, we don't have to. We're going to solve for P, round it to the nearest tenth. We're going to solve for Q, round it to the nearest tenth, and then add. Actually, sorry, we're going to solve for P and Q, then add everything together, and then round, because it's the last thing we do. Okay. So little p is r sine P over sine r. So now we fill in the numbers. 12 sine 63 degrees. Over sine 92. And same thing here. R12. Okay, so I'm going to work these out, clear that out, and then we'll just add those numbers together, the numbers we calculate, plus 12. So I'm going to go 12 sine 63 bracket. So you do have to close the bracket there. Divided by sine 92. Okay, so 10.698, so 10.6985. Dot, dot, dot. So I'm going to say that number keeps going. And then Q was 12. Actually, you know, it's the same calculation. Just 63 is 25, right? So I'm just going to copy it down, bring it down from the 5.0745, dot, dot, dot. Okay, and then the perimeter equal to 12 plus P plus Q. So on the calculator to do that, I'm just going to go plus 12. So that's going to pull that number down, and then go plus. Jump to the other side here. And go up and pull this number down. So the ANS is the 5.0745 blah, 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 right? Plus 12 plus this number. So just pre-working this, I'm going to get, what, like 15 and 12 is 27 and change? Okay. And so 27.77, so the answer is 27.8. So 27.8 what? Centimeters. Okay. So there you go. So if they had not given us centimeters, we would just go 27.8, right? It's just a number. Units, you could put units. Any questions? Okay, so 2 applications of the Sine Law. All right, let's keep going. More of the merrier. Solve the triangle. What does it mean to solve the triangle?
Find all sides, find all angles.
Yeah. So you got to come up with 6 measurements, right? 3 angles, 3 sides. We already know 3 of those 6 measurements, right? So we have to find angle A, angle B, and little b. So we just go ahead and label. So this is little a. So say maybe A equals 5, C equals 8. Here's little b. Do we have a known pair?
Yes.
C. So what's the first thing we're going to have to find? Yeah, so it's the only thing we can find, right? So the only thing we can find right now is angle A. So we're going to set it up this way. The unknown, that which I want to find, is A, so I'm going to write sine A. This is going to require an extra step, right? Because it's the sine of angle A. Yes.
Why can we find angle B?
Because you don't have little b. Okay. No b. So in order to solve this triangle, we will have to use a calculated value, right? We will have to use angle A to then get angle B, right, with the 180 thing. Okay, so the sine of angle A over little a is equal to the sine of angle C over little c. So sine of A is equal to A sine C over little c, and angle A is the inverse sine of that expression. So we can go directly to angle A by doing the inverse sine of and then substituting in the numbers. So we know little a, little c, and sine C, right? Okay, so angle A is equal to the inverse sine of little a, 5, times the sine of 50 degrees over 8. Okay, so second function, sine inverse, 5, sine 50, bracket, divided by 8. Close bracket. So order of operations is going to take precedence here, right? It's going to go 5 times the sine of 50 and then divide that by 8, which is what we want to happen. Then it's going to do the inverse sine of that. So let's take us directly to the angle. So here's a hint. If you end up with A is equal to, you get a number between 0 and 1, then what you found was the sine of A. You didn't find A. Okay? Or you look at that triangle and you go, wow, A is like, 0.4 degrees. And you go, no, 0.4 degrees would be the lines are almost right on top of each other. Okay? So if you're ever solving for an angle, you get a number between 0 and 1, do not use that number. Do not multiply it by 10 or 100, as the case may be, just to make it a better angle. Just say, oops, I found the sine of that angle, so I'm going to go second sine inverse, second answer, right? Just do the sine inverse of the number I found. So that would have happened if I had done this. 5 sine 50 divided by 8. Okay, 0.47877, right? You got to say, that is not less than half a degree. Okay, so then you go second sine inverse, and go second answer to pull that number in and get the 28.6. So 28.6 degrees. So A is equal to 28.6 degrees. 28.6 degrees. What's that make angle B? 101.4, right? So it's 180 minus 50 plus 28.6. 101.4 degrees. Okay. So we do have to use that calculated value, right? Then we're going to go, what do we have to find now? Little b. So b over sine b is equal to what? Yeah, c over sine c. Don't use a, right? That's already, we already had to use calculated value. Okay, let's use the exact values here so we know this is little c over sine c. So b is equal to c sine b over sine c. So when you're solving for a side, you don't have to worry about doing any inverses or anything, right? You're just going to get the number. It's going to make sense too. Is b the biggest side, the middlest side, or the littlest side? The littlest. Biggest, in between, or the smallest? It's going to be the biggest, because it's opposite the largest angle. Okay, we got 50 degrees, that's the middle then, and we've got 28.6 degrees, that's the smallest side. So smallest side, opposite the smallest angle, biggest side, opposite the biggest angle, etc. So b is equal to c sine b. Now, I'm just going to use the b that's sitting in my calculator, right, which I'm about to calculate because I didn't do it in the first place. So it's c, which is 8, sine b, okay, like from calculator. Okay, that way I'm not rounding, over sine 50 degrees. Okay, so step one is to actually get that angle calculated. So I'm going to go 180 minus 50 minus second answer, right, minus that number. So there's my 101.4, right? That's what we're giving as an answer is 101.4, that's fine. But for the calculation now, I'm going to go 8 sine second function answer, right? Bring down that number. It's exact, right? I'm not supposed to round until the end, so bring down that number. Go 8 times the sine of that number, divided by the sine of 50, right? Close the parenthesis so it's all pretty, and 10.2. Okay, so b is equal to 10.2. It's not likely to make a difference if I had used 101.4. Oh, you used it with 101.4 and it was off?
No.
Oh yeah, it's going to work fine. All right, the only time that it wouldn't work fine is when you're that close to where, you know, you're rounding. It was like, whatever. The numbers just work out that close to each other that just that little bit would kick it over the top. All right, so solve the triangle. We have angle A is equal to 28.6 degrees. Angle B is equal to 101.4 degrees. Angle C is equal to 50 degrees. Little a is 5, little b is 10.2, and little c is 8. There's a nice little chart, right? I mean, what you really needed was, okay, like, I needed to find this. I needed to find this. Probably should list that somewhere else. And I needed to calculate that. Okay. So that's a solved triangle, all 3 sides, all 3 angles.
Did you just
No, it's not a right angle triangle. Sorry, which question?
oh, sorry. That's what I was asking.
Yeah. Years of doing this. Yeah, no, it's not a right angle triangle. So the question was going to be, can we use Pythagorean theorem, right? And the answer is no. It's not a right angle triangle. Okay. So Pythagorean theorem and SOHCAHTOA only work when you have a 90 degree. The 90 degrees you get could be calculated, but then make sure it comes out 90, nothing else, right? It can't be 90.17, it's still not a right angle triangle. right? Or they indicate, right? Angle this is 90, or the diagram is there and you see the little corner box. You know, so if they draw a triangle, like this, don't assume it's 90. You need to either be told like angle A equals 90 degrees, or you need to see this. If you don't see that, if it doesn't specifically say this angle is 90, then no matter how 90 it looks, it's not. Okay? Unless you can show otherwise. Determine, which means what?
Show your work.
Show your work. The area of the triangle shown. Round it to the nearest tenth. Okay, what's area? Triangle.
Base times height divided by the
Okay, so what do we need to find?
base height.
No? We got the base. What do we need to find?
The height.
The height. Where's the height?
In the middle.
Okay, so we need to find h. We know the base, right? B is 10. All right, here's the problem. We don't really know much. We don't know how that 10 is split amongst those two lengths, right? We do know they add up to 10. So what are we going to have to do first? Yep. Third angle. Okay, we can do that. What's third angle? 80. Okay, now that we got third angle, what can we do? What do we have to do? We need one of the other sides. Once we got one of the other sides, then we can use SOHCAHTOA, right? Because then we have a 90-degree triangle. So the problem is, before I do this, and put the h, it's like, well, I got a 70, an 80, or sorry, this is not, it's not 40 on each side, right? Because that's not splitting that angle in half. Okay, it's not bisecting. You can tell it's not bisecting it, right? It's not definitely in the middle. So, problem is we need another side. Okay, which side would you like to find? So which one? Opposite of the 30 or opposite of the 70? So let's call this A, B, C. This is little a. This is B. This is C. What do you want to find? Really? Because I know that the sine of 30 is a half. Right? Which means that, yeah, you know, I take h and double it, I've got my, okay? So, we'll go for the, it doesn't matter, right? You can use the sine law either way. Okay? So it doesn't matter. So we're going to find little b. Then we're going to use that with this 90, this 30, opposite over hypotenuse, etc. Right? And we can solve that without a calculator. It doesn't matter. We got calculators anyway, right? It's like nobody's taking away our calculator. Okay, so we're going to find little b. So b over sine b is equal to, what do we know? A. We know A and sine A, right? Angle A. How do we know angle A? Because you got two angles, you got three angles. Right? A little bit of calculation, you get that. Okay, we want to find little b, so b is equal to A sine B over sine A. Okay. Just the way, I like to solve it this way, right? Because it's just like rearrange it, and then all I got to do is work out what's there. So A is 10. So 10 sine 70 degrees over sine 80 degrees. Little b. Little b is, I mean, in a sense, you don't necessarily need to actually work out little b. You need the number, you don't. Uh, 9.5418888, blah, 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 blah. So here's our 9.5418, blah, blah, blah. So what I'm indicating to you, I'm not rounding this, okay? But I don't feel like writing out the whole thing. I'm going to write out a few decimals, right? I'm not going to round this because we're going to be using it in a subsequent calculation. Okay? So B is kind of unfortunate that I labeled that. The area now is going to be A times H over C. Okay, so now we're going to use the h and the b. We're going to use the b to get the h. Okay, now it's a right angle triangle, so we could say sine theta is equal to opposite over hypotenuse. Okay, so sine 30 degrees is equal to h over b. Okay, wait, we know b, right? H over 9.5418. H is equal to 9.54. So I know it's like 4.7-ish. Sine 30 degrees. Okay, nothing gets rounded, right? We just used, so I've got the number, the 9.54, that's sitting in my calculator. So I'm just going to go times sine 30, right? Which is times a half, but sine 30. Okay, 4.77, 4.77, and more. Okay, area is equal to 10 times the 4.77 divided by 2. Okay, so base times height. We got the base is 10. Now we've got the height. All right, we just work that out. But again, it's sitting in my calculator, right? So I'm just going to go times 10 divided by 2. I could have just gone times 5, but whatever. 23.85. Rounded to the nearest tenth. 23.9 what? Centimeters squared. Okay. So area is equal to 23.9 cm squared. Okay, so two-part problem, one part which required sine law, one part which you could just use SOHCAHTOA. You could equally have done the sine law. It wouldn't matter. It's a waste. Okay. Solve for x, rounded to the nearest tenth. Okay, to get x, what are we going to have to get first? So x is in a nice right angle triangle, right? So what do we want to find? We need to know another side in that triangle, right? Give me any other side, I can get x for you. The angles? What angle? What is this angle? What is this angle? What is this angle? So you can label them all. Okay. It's a 30, 60, 90 triangles. 90 and 60 is 150, and then you got 30. Okay. Yeah. So now we can work with anything, right? And it's just like take a moment and just say, hey, yeah, I can just label the other angles in the triangles, right? Will I need them? Maybe. If I don't need them, did I spend a lot of time working out angles unnecessarily? Not really. Okay, because it was seconds. It's not like, oh, I got to take 5 minutes to figure out these angles. So if you can look at a diagram and just sort of glance at the question and just say, well, let me label everything else that's in here just because. If I need it, then it's there, right? Okay, so what are we going to work out? So let's call this A, B, C. So then what do we want to find? Little c. If we find little c, then we could just use SOHCAHTOA, right? Because we got a nice right angle triangle. Actually, the so part of SOHCAHTOA. So somebody said Pythagorean. I don't think we could use Pythagorean. We need, yeah. Oh. Okay, wait a second. What side?
The angle, the side.
Yeah. Yeah, that's a waste of time, right? It's like, let's solve for a side so we can solve for the other side, which we could have solved for in the first place without solving for that side as well. It's okay if you want to spend more time. You know, you're going to get the same answer. Just remember, don't round. Okay? If you do solve any intermediate calculation, should never be rounded. So you can indicate that on your test paper by just writing, you know, A equals 9.72, da, 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 da. You know, put down the 3 dots. Just indicating I'm keeping full accuracy, don't worry. Okay? So I'm not worried, because if you don't, and it's numeric response, you run the risk of just getting the question wrong. Okay? Being off by a little bit. All right, what are we going to find? C. C over sine C. What's our known pair? A. So A over sine A. Okay, remember, we're finding an unknown side, so we're putting the thing we want to find is always going to go in the upper left. Okay, rearrange equation before substituting. I think that's a nice thing to do, better thing to do. Okay, what do we got? A, 10 times the sine of 20 degrees over the sine of 40 degrees. And remember, we're going to keep this number, sine 20 divided by sine 40. Okay, so we got 5.320 dot 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 08. And then, what are we going to do? Get x. How are we going to get x? So we're going to start with sine theta is opposite over hypotenuse, right? So we're going to communicate sine of 60 degrees is equal to opposite, which is x, over the c, which is 5.3208 dot dot dot. So x is equal to, okay, it's going to be that number times sine 60, okay? I don't need to see that bit of it, so just go here, times sine 60, and we get 4.6, which is what, rounded to the nearest tenth, 4.6 units, meters, okay? Make sure you have units on there, okay? Don't want to lose a half mark. Nope, it's not an area. Okay, is that it for sine law? Okay, so sine law. You need a known pair. You must have an angle and the side length opposite that angle. Okay, now we know something about triangles now, which is smallest side, smallest opposite, smallest angle, etc. Biggest side, biggest angle, middlest side, middle angle. Set up the equation. The form of the equation you're going to use is to put the thing you want to find in the upper left. Rearrange the equation beforehand. If you're solving for an angle, make sure you do the sine inverse of that expression. If you don't do it before, then you're going to get a number between 0 and 1, and you're going to say, we do not have any angles between 0 and 1. That's not it. I have found the sine of the angle. I have to find the angle. All right, tomorrow, ambiguous case. And now we're done. So how's that work?